Hey guys, so I decided just to record this video with anticipation of us actually having a snow day. The dates and stuff might be a little bit weird depending on when you're watching it. So please take notes. If you don't have a printer, I posted the video like notes online, but if you don't have a printer, you could always just do these on loose leaf. I know it's a little bit of a pain, but I know we don't have a printer at our house anymore. So feel free to do that and just take notes as needed. Please make sure you do take them, though this is going to be a tougher lesson to remember later on. So we're finding the value of the variable here. Hopefully you guys remember that we have these straight lines here. So that means that this together should be 180, which means that this would be 60. The 60 and 120 would give me 180. And then I have vertical angles here that would tell me that this is also 60. And same thing here, that this would also be 120. So we can work our way around the shape using our linear pair and vertical angles to figure that out. So X, Y, and Z, I can figure those out. Please make sure you use the degrees when it's degrees. So we're using this in what we're talking about today. So, and if you think about it, if I draw this all the way around, it really is, it's a pretty lopsided circle, but it's a circle. And that's what we're going to be talking about today in terms of our angles inside of our circle. So I'm going to talk to you guys about what a central angle is here. So the drawing we have here has like a bunch of different central angles drawn at it. So a central angle is kind of what it sounds like. It's at the center. The vertex is the center of the circle. So, like for instance, angle 1 would be what we call a central angle. But so are angles 2, 3, and 4. So angles 2, 3, and 4 are also all central angles. Now I do want to point out what's not a central angle, so we'll talk about a drawing like this later. So something like this is not a central angle because it's not centered at the center of, so this is not a central. We'll talk about those types later, but that's not considered a central angle. So make sure that's clear over there. So the sum of the central angles, if I add them all up, in this shape and go all the way around, they should add up to 360 degrees. So angle 1 plus angle 2 plus angle 3 plus angle 4 should add up to 360 degrees because that's all the way around a circle. So the sum of the central angles should add to 360, always. And feel free to pause me as needed. I'm going to kind of keep plugging along here because I'm not teaching in front of anyone right now. I'm talking to myself. Zippy's watching. So in this case, we want to find the value of X. And so that's this angle here. But they have these two marked for me that these are each 90. Because of those little right angles, those still exist within circles. So I know that X plus 90 plus 40 plus 90 should equal 360 degrees. So I'll put these two together, or all three together. So X ends up being, I move this 220 over. X ends up being 140 degrees. Which if I go back and look at my drawing, that makes sense. It's an obtuse angle, it looks pretty reasonable that that could be 140. All right, so talking about that, we're also going to talk about, so we talked about these angles, but then the arc is kind of the outside of the circle part. So the arc that I'm talking about would be this outside edge. So if I was talking about this as a lake, this would be like my lake frontage on my house. So the arc, so that's the part of the edge of the circle. Whereas the angle is the inside. So here's the angle, and then this is called the arc. So the angle is that inside part, the arc is the outside part. Now that arc measure is measured in degrees, and it's the same as the central angle's measurement. So it's the same measurement. Measurement is the central angle. So if this is 140 degrees, this is also 140 degrees. So I'm going to show you guys, we're going to talk about minor arcs versus major arcs, and talk about kind of how they show these in our textbook. I might actually grab my textbook here quick. Trying to make sure I use the same symbols as they use. So I'll try to. So our minor arc is like the short way around a circle. So in terms of this arc here, if I'm talking about arc AB, and so they use a little arc over the top, the minor arc would be the short distance between A and B. So like if I was talking about, I own part of this lake frontage, I own this short part. So it's the shorter distance between 2 points. And it's going to be less than 180. It's going to always have to be less than 180 because 180 would be straight across. And so we always want to go the short way here. So it's a less than 180 degrees. And this arc is going to be the same as that measure. So when I say what's the arc equal to, it's equal to that central angle. So the arc equals the angle. Then the major arc would be like going the long way around. And rather than just using the same 2 letters, the A and B, what they're going to do to help you with this is they're going to use 3 letters. So they're going to call this arc ADB. That way I know I'm going through D to get there. So I'm going the long way around. So it's the longer distance around the circle. It's going to be more than 180 degrees. And the way we figure this out, if this is x over here, the whole way around is 360 degrees. So to figure this out, I'm going to have to do 360 minus x to figure that out. So I'm going to take the whole circle and just take away that little part that maybe you don't own. Like you own most of a lake, but you don't own this little section, and that's the part we're leaving out. So they use the 3 letters on the major arc. That way I know for sure that I want that longer arc. And the last one is a semicircle, and you might have, I remember in kindergarten our teacher telling us to sit in a semicircle. It means just a half circle. So it's just halfway around. And so when we go to talk about this one, we say the endpoints are on the diameter of the circle. This one's exactly 180 degrees. And it doesn't matter really which way we go to measure, it's just going to be 180 because this is a straight line. So our diameter goes all the way across our circle, which our diameter is AB. And we don't need to use the letter, we could call it like this. If you want to be more specific, so you want to know which way we're going, you could use the third letter, is fine. It's optional. And we know this because AB is the diameter of the circle. And remember, our last class we talked about the diameter being straight across through the middle. So that's our semicircle. So I'm going to flip to the back side. We don't really have much more to go. Again, if you have these to print, otherwise you can just kind of sketch them in your notebook or on loose leaf or whatever you guys have at home. So we're going to talk about congruent arcs. And so congruent just means equal. So obviously that's arcs that have equal length. So they're going to have the same size central angle, but they also have to have the same size radius. So I can't have central or congruent arcs and to draw like this really kind of quickly here, and I'm going to erase it in a second. So if I have a small circle and then I have a big circle, even though the angle's the same, this arc is obviously going to be shorter than this one. So those would not be congruent because they're different size circles. So just to make sure that's clear, so those would not be congruent. So let me get rid of those. So congruent arcs, they have to have the same central angle and the same length radius. So congruent is equal arcs. Oh, I guess I have a good example of not congruent arcs there. So I didn't notice that was there. So these ones, they have the same length radius, they have that marked, and then they have that same central angle. So in this case, AB would equal CD. Whereas this one is not congruent because 5 doesn't equal 4. So we would say in this case, MN, we'd say does not equal PQ. Oops, that should be an R. You could say it's going to be greater than. That's going to be assumed that that's going to be greater than. So these are not equal because of the 5 and 4. So they're different size circles. So it's like comparing, you always hear comparing apples to oranges. They're not identical. The next one are arcs that have adjacent arcs. So adjacent, reminder you guys, is next to. So I'm going to just write next to here to remind you of what adjacent means. So they're arcs that share an endpoint. And I'll show you guys a little example of this. So I'm going to draw a circle here. And I'm going to put a few points along. So M, N, we'll call this P. Adjacent arcs would be arcs that are right next to each other. So M, N, and NP would be adjacent. So they're right next to each other. So they're kind of like where one leaves off, the next one starts. So this is adjacent to this one. So they're right next to each other. And then our last question here, and kind of getting into some algebra with it or figuring out some different measurements. I guess we have one more thing we have to discuss. The arc addition of postulate is basically, I'll go back to this example to help me with this, is that I can add those arcs together and we can assume they add up. So like the arc addition of postulate says that if I say mn and I add it to np, whatever those lengths or measures are, it's going to equal the whole thing. So I'm going to call that mnp. You could just call it mp. So that you can add those arcs together. So that's kind of assumed maybe, but I want to make sure that's clear. So our example here, and then I'll give you guys, the rest of the time will be for you guys to get your homework done. Hopefully you should be able to figure out a lot of these. So it says ln and hk are diameters. Find LHI, so this, and then I and k, which is this. So sometimes they use 3 letters when they maybe don't necessarily have to. Li would be assumed, but it kind of helps you to know it goes through H. So they tell me these are diameters. So that's telling me that they're straight, so that's 180 degrees. But I know already that this is 90, right, because of the right angle there. But again, I have this straight line here, so I should be able to figure out this angle or this one because they add up to 180. So I'm going to call this x here. So x plus 32 plus 90 should equal 180 degrees because this is a straight line. So I'm going to move that over. So I find out that x is going to be 58 degrees. So this is 58 degrees. But then hopefully you guys notice this across from it is also 58 degrees because we call those vertical angles. Or you could have also used the fact that this is also a diameter. So now I should be able to figure out the LHI. So LHI is this. And so that's just those 2 angles together. And they use this little measurement thing. It just means the measurement of that arc. So LHI is going to be 58 and 32 together. Oh, and so that ends up being 90. And maybe you realize that because this is also 90. Maybe, hopefully, maybe you saw that before I did. And then our I and K. So I and K is going to be 90 and 58 together. So this is going to be 148. And so that's what we're doing there. So our homework, you guys, is going to be in the textbook. So again, just like we typically would, you can look up that online. And you're doing 3 through 19 all. So please bring this along with your other assignment from your 10.1 to class next Tuesday. All right, hope you guys have a good day.